Hey, this is Patrick again, and after an extended break, I am back with a new video titled AV Alerts, Webhooks, and the Serverless Swiss Army Knife AWS Lambda. There are not as many tools in AV as there are in software and network infrastructure engineering, which leaves people like me the space to build tools where one day products will exist. I believe in a three-pronged approach to AV monitoring, and I think that by far the hardest one to get right are the real-time alerts. We can either build a polling mechanism or we can depend on webhooks from the manufacturer's server. This video is about the latter. How do you sift through the chaos of an entire suite of technology and find an actionable item that you can catch before the users? In a world of network-connected devices, things go on and offline all the time. It's very hard to know what is worth your immediate attention and what isn't. I created these AI images to demonstrate a similar principle in information security. Our main goal is a true positive. It requires our immediate attention. Our second goal is a true negative, filtering out events that don't. False positives strain our attention, and we eventually filter out the whole system. False negatives are the worst of all, a breach on a system that we thought we could trust. Last, even though I don't care about those true negatives in real time, I might want that data to look at patterns and other detailed metrics. Kind of like what I'm doing here with these webhooks from Zoom. It might also be the case that I want to forward those webhooks to a different service like Slack, or I want a user's action in Slack to post a modification to Zoom. I'm using a tool in AWS called Lambda to handle a lot of these actions. It's so handy that I called it the Serverless Swiss Army Knife. Why don't we get started? We're going to log into the AWS console and set up a new Lambda function. We're just going to parse incoming headers as authentication, which is not a good idea but makes for a nifty tutorial. After just a few button clicks, look what we got, a public URL and code that we can edit. We edit the code, open a new tab, and go to the URL, and look what we got. Not a bad setup. Control code, public URL, and somebody else's servers. We can start logging all requests to that URL and then tail the logs using the AWS CLI. Take a look at the event header right here. We can also go in and just parse out the event body as you see in this example right here. If we were to use curl to send it a post request, you would see that body of data in the console. The last thing we'll do is add a few filter patterns to reduce some of Lambda's default logging. This video is all about using a modern toolkit, so we're going to bring this entire application into our Cursor IDE and use Anthropic's Claude to help us write some of the code. It really helps if you know what you are doing, or in this case have already written the application without AI before you start vibe coding yourself into a huge mess. Give the AI small but digestible prompts, one feature at a time, and maintain portability and modularity. Build it fast, but keep it smart. Don't buy yourself the tech debt. Now that we had it create the post request that I already sent in the terminal, we're going to pull down the runtime into our local environment. The AWS CLI will help us download the zipped Lambda function. We're going to unzip it here and start to interact with it in our local environment. Since it is a Node.js runtime, we're going to use Node's package manager. This allows us to build and run scripts that let us interact with the Lambda remotely, as well as import and utilize external modules. Watch me update the code in my local environment, and then I can run the deploy script that I created, and when I look at it remotely, it's been updated. Now we can spin up our first service. We are going to forward webhooks from Zoom into our Lambda. The first justification for building our own program in Lambda is the authentication flow from Zoom webhooks. You can see in the Zoom docs that the example that they give us is conveniently provided in Node.js. Zoom gave us an API key which we need to add to our Lambda. We are going to encrypt this API key in REST. Hardening security like this involves a lot more complexity in another AWS service called KMS. However, it's well worth it because otherwise you would be able to see the API key in some packets between your environment and the cloud. AWS gives us some sample code that shows us how to decrypt that environment variable. And conveniently, it's also in Node.js. And this is obviously not secure at all, but you can see me build the decryption flow and then I can print that API key into the console logs. You definitely want to cycle that API key once you're done doing something like that, but in this case I just spun down every asset that you see in this video. Now that we are decrypting the API key properly, let's get back into Zoom's validation flow. I import the dependencies, I add the necessary code, I think I see the right data body in the console. However, I try to run the validation and no dice. Luckily, I am still capturing the entire request in my logs, including the header. So why don't I see if the AI can give me a hint? The AI might be giving me 20 minutes or more of my life back, but is it dulling my software skills over time? It's hard to tell. But for this tutorial, it fixed the issue and allows us to move forward to the next thing. Now that we're validated, we'll go ahead and add which events we want webhooks for. And you can see them start to hit the logs in real time. As we build out this app in complexity, we're going to start separating services. This is where AI can really mess things up, so tread lightly. We're asking it to move all authentication-related items over to a different file so that we can keep the index.mjs file clean. More importantly, it's going to update the model's context. It's telling it, hey, think about new features in terms of new modules and new files so we can pull them apart, parse them, or delete them as needed. This will keep the agent from going off the rails. Here is our next service, QSys Webhooks. No authentication or scopes, hopefully a lot of features in the pipeline. You may have noticed that I told the agent to forward the entire payload if it came from a source that it didn't recognize. I can add that entire header and body back to the agent and tell it to build a handler for QSys. Speaking of QSys, there's no reason we can't add behavior from a touch panel directly to the Lambda. Maybe you want to build a dashboard that tells you how users are using a given system, or perhaps you want to build some kind of two-way help desk between a different cloud service like, let's say, Slack. Watch me take the payload that I'm forwarding from this interface and see the power of building good context. At this point, the agent has a pretty clear idea of what I'm trying to do with this app. Why don't we fold in a new service? This time let's bring Slack into the mix. We'll head over to the marketplace and we'll spin up a new app. Slack, similar to Zoom, is a very evolved piece of enterprise software. There are a lot of options to choose from. Once we get that published, we can add the API keys to our Lambda. And again, the docs give us an example in JavaScript. My trust in this agent is completely contingent upon the knowledge and strength of the context that I've built. I'm letting it run wild a little bit more, but I'm still reviewing everything that it writes. Before I publish an update to the Lambda, I need a Slack channel ID and therefore a Slack channel, so I'm going to go ahead and make one. Notice, however, that I separated concerns within the context. I had it build the Slack module first. Only then did I have it start doing inter-channel communication, which is going to combine services. We're going to have those Slack buttons go back to the same Lambda. That's where the Swiss Army knife principle really starts to come in. I've got everything set up and deployed, and now I want to start sending those QSys button presses to the Slack channel. However, I can't see them because I'm completely overwhelmed by this real-time sensor data coming from Zoom. That sensor data makes for a great dashboard, but it is way too noisy for Slack. Here you can see my first major AI fail. I told it to filter out the sensor data, but I never gave it a sample payload of what that data is. So the agent just hallucinated its own. Why don't we go ahead and add the right data ourselves? After we push an update, you can see in the console logs that it's filtering out the data from Slack. Now I'll go ahead and test out the QSys interface and make sure that it's forwarding those button presses to Slack. Check it out in the console. Last feature for this video. What if every Zoom alert that went to Slack, we instead gave the user the option to post data to the Zoom APIs? Right now, this proof of concept just has a test 1 and test 2 button that don't do anything. We'll add a modal, which is Slack's terminology for a pop-up window that gives us a text box and lets us rename the Zoom room. Kind of a silly example, but just showcases what's possible. Being able to modify our Zoom configuration is not the same thing as listening for Zoom events, so we need to spin up yet another app. This one interacts with the REST API. We'll do the same thing. We'll grab a specific part of the docs and feed that to a very specific prompt. And before we start combining services, we're going to build out a specific module custom tailored to the Zoom REST API. It's extremely helpful if you've built out something like this before. Once the code is deployed, we'll go into the Zoom admin and we will build out the new app. After we add the scopes, we will add the API key to the Lambda and we will encrypt it like we have before. All of that code looks good to me, so I'm going to ship it. Once it's shipped, see the text box pop up in Slack. We will deploy the change and hop over to Zoom admin and see if it took. And sure enough, there you have it. I changed the name from the Slack app. That is the end of this video. How many different services was I able to combine? Hopefully now you can see why I gave it the name, the Serverless Swiss Army Knife. I love having the opportunity to solve business problems with modern tools. Catch you next time.